Okay, welcome to GTI Predictive Technology. We're here to do another video on our iPad vibration analysis system. People that have seen this system before, this is what it looks like. This is an iPad Air. We have a 2-channel DAQ box on the back, which we're going to be using both of those channels in this video. Both channels go to the 2 accelerometers here. You can see my first accelerometer is on the driven motor. And then between the driven motor and the base simulation I have here is a nice thick rubber pad, which is my isolator. And then I'm going to be running channel 2 on the base. And what I'm going to be measuring is the transmitted vibration between channel 1 and channel 2. And at the end, I'm actually going to be able to print out a plot that's going to show the dampening ratio, the amplitude ratio, and the frequency ratio between them, so I can make good, intelligent decisions on whether I have a particular asset or machine dampened or not, or I'm approaching its natural frequency. So I'm going to go right to the video here behind me and show you what it looks like on the iPad. I'm going to open the app up. And immediately on your right, you're going to see measuring the natural frequency. That's what we're going to do first. Second, we're going to measure the transmissibility, and then we're going to generate the plot. So as we go into it, we just tap on it, opens up, and you can see there's an arrow right next to the hammer there where it shows me that I've got to do the tap test. I'm going to tap this. I'm going to see the frequency. I'm going to highlight it at 14.79, and then we're going to switch over and we're going to turn this motor on. And you can see immediately the frequencies come right up, and I can see the percentage of 35.25% between the two. I record it, and there I have my plot. And the plot shows where my natural frequency was, and I'll discuss that a little more in detail as we go along. But real quickly, you can click the camera button, take a picture of the device that we did the test on, so it's part of your report. Once the report is done, it's simple to hit the email button. As you can see behind me, we're going to email this, type in a few letters, hit the person's name, hit the send button, off it goes. It is simple as that, and very much like our VibePro and other apps. And now I'm going to just show you I can quickly put a test or a name or a machine name under there as well, and just flash back to the main screen where you can see it operating again. And I'm putting the cursor, the manual cursor, on another frequency there so that you can actually measure 6.14% between that frequency. So it's very versatile for identifying other frequencies other than the running driven frequency of this unit. But let me put up the transmissibility report one more time so we can explain a little bit about this, what this is about. Number one, you'll see channel 1 and channel 2 there. I'm looking at both amplitudes of channel 1 and channel 2 and the frequency that it's at. And you can see my frequency is at 59.18 hertz. And below that is the percentage of vibration between channel 1 and channel 2, which in this case is 35.09%, as you can see up there. The next value is when we did our tap test, that was the natural frequency of this particular motor, and that was at 14.79 hertz. And then below that is the ratio between the driving frequency and the natural frequency, and that is at 4.0. And then the second last line, I should say, is A1 and A2. And what that is the amplitude ratio between channel 1 and channel 2. And that one came in at 0.35%. And then the last one is your dampening ratio, which is most important. What is our ratio between of our dampening system? And that is a 0.70. And you can also see on the chart here, as we draw that red line across, the red line vertical shows us where the running speed of this driven unit was, where the small hump you see on the black line is the natural frequency. And as you can see, if I run my motor, that red line closer to that the natural frequency, I am going to have an elevated amplitude between of vibration transmitted, whereas if I run it faster, as you can see the plot decreases, I will actually be running in a better zone for not as much transmitted vibration. So quickly we can see between what the running speeds are of these devices with this unit, we can tell where we want to run, as well as what good or intelligent dampening system we put between our assets and the floor and or the base of what we're utilizing.